So guys, today we are going to see the project demonstration of a smart element with advanced driver assistance system ADAS. So this concept was developed for a two-wheeler helmet. So actually we know that helmet is a very important factors for two-wheeler drivers. So here in that helmet we are going to integrate some sensors for the safety drive. For example here, so advanced driver assistance system ADAS will give the added advantages and security to the two-wheeler drivers. Drivers or riders we can use for both. So here these are all the components we used in this project. So actually the concept of this project is this smart helmet will detect some kind of violations. For example, the first condition is a collision warning. So if a two-wheeler is going to have a collision, it will automatically detect and send the report to the particular caretaker or nearby police station or nearby ambulance automatically. And the second thing, this helmet will automatically detect the drowsiness. So we are going to fix some kind of sensors and it will detect the drowsiness and it will update the same. And also it will detect the alcohol. If the rider is taking alcohol trying to move the bike means, it will automatically detect and it will give the warning. And also we can able to disable the engine if alcohol is detected. And third thing is a color sensor. So we know very well the two-wheelers will violate the road. The two-wheeler violates the road lanes. They will cross the lanes and they will override the lanes, and they can have a overlapping of traffic. So here the lane detection will detect whether the particular rider is crossing the lane or not. And the second ultrasonic sensor will be fixed in rear side of the helmet, so it will detect the blind spot. So if anyone is trying to eat in the back side, it will automatically detect. And also the entire circuit will be connected in the Arduino. The Arduino was inbuilt Wi-Fi. So to the Wi-Fi, the entire operations will be taken to the IoT. Through the IoT, we can able to clearly have a data analysis about the particular rider. And also there is a buzzer attached with this circuit, so it will give a clear warning about each and every sensor separately. And a GPS was attached to track live route of that particular people. We can able to track them from IoT page anytime. So the complete circuit will be powered by a power supply unit separately. So this is how the concept has been framed. These are all the components we used in these projects, and this is the report. So let us see the live demonstration. So guys, as I explained in the block diagram, the components have been arranged in the helmet. So this is a prototype. We have integrated the sensors in open environment, but these sensors can be integratable in a helmet. So let us see the components. So this is a GPS, rear side ultrasonic sensor, and a push button to start the project, and a drowsiness eye blink sensor, microcontroller unit, Arduino Nano, and Wi-Fi. BMOS will be given here. So lithium ion battery was separately given in the helmet itself. These are voltage regulators. Buses are attached in a general purpose dot board. And coming to the other side, so front side ultrasonic sensor is there, alcohol sensor is there. So the first condition is and in top of the helmet the color sensor was given. Actually that color sensor should be attached in the vehicle, so for demo purpose we've attached in the top of the helmet. So the first condition, before start demonstration, we need to give the internet connection to the helmet. For that we are going to setting our hotspot. So once the hotspot is get connected, the complete information about the helmet you can able to see in the IoT web page. So this is IoT page. So this web page can be converted into Android app also. So here you can see the complete informations of the sensors. So this is a history of that sensor. So with the date and a particular date and time, you can able to see the sensors values. And also in the map, the live location was plotted. Actually we are in indoor, so we can't able to see that live location, but it will work in the outdoor. So first thing first, I'll show the collision sensor. So if any object come in front of the helmet very closely, so the collision sensor will give a buzzer sound. So that is collision warning. So you can see collision warning. And so if a collision is occurred, it will automatically send some kind of information to the particular respondents. And second thing, we are going to see that blind spot detection. If any objects come very near to the rear side, it will automatically detect and it will give a warning, that rear side collision warning. And for lithium ion battery, a charging port is separately given. And let us see the alcohol detection. Actually I used the IPA solution for alcohol. IPA solution have the alcohol content. So if alcohol is detected, so it will display that alcohol is like that. So this is a drowsiness detection. Actually we need to integrate this sensor in a helmet glass. So instead of that, I integrated in a normal glass. So instead of doing with the high, I'm just doing with the fingers. So if the eye is opening and closing, then it will automatically detect normal. If the eye is permanently closed or permanently open, it will say the drowsiness detected. So for lane detection, I have taken two pieces of paper. One is a white one and another is a yellow one. So if the vehicle is crossing a white line, the IoT will detect. So it's crossing the white line. So based on that, it will give a warning. If they are crossing white line, no problem. If they are crossing the yellow line, so the yellow line means you should not cross the yellow line. So if the yellow line is crossed, the warning will be given. So in lane status, you can see that the yellow lane is detected. Okay guys, I hope you understand the demo. Let us see what are the things we'll give along with this project. So we'll give a fair documentation along with this project. The documentation includes a content like a title, abstract, existing system, disadvantages of existing system, proposed system, and advantages of proposed system, block diagram, and block diagram of IoT side, system specifications like hardware and software specifications, modules, module descriptions, literature review, and hardware descriptions. In the hardware description, they clearly given the details about the hardwares whichever you used in this project with some examples. The hardware descriptions will be described with some examples. And software description, in the software description they give detailed about the software languages, programming languages, and the IDE which is used to program, and a basic information about the IoT. And finally the result will be discussed here, and the conclusion will be given based on the result. And finally the references whichever taken for reference to complete this project. So the complete fair documentation will come around 35 to 40 pages, and we'll give the source code screenshot separately. So if you attach with this documentation, will come around 60 pages. So guys, hope you understand the concept. If you require this type of project, or if you need help to complete your project, you can contact our executive from the number given in the screen. Thanks for watching. Have a nice day, and keep subscribe our channel to get regular update about the latest technology and project demonstrations. Bye.